everyone, so for today, we are going to solve this problem. Water is poured at the rate of 8 cubic feet per minute into a conical shaped tank, 20 feet deep and 10 feet in diameter at the top. If the tank has a leak in the bottom and the water level is rising at the rate of 1 inch per minute, when the water is 16 feet deep, how fast is the water leaking? Now, in this problem, we are going to find the leak rate of the water in the conical shaped tank. The very first thing that we need to do is to illustrate. We have been given the height of the conical shaped tank at 20 feet with 10 feet in diameter, and the height of the water at 16 feet deep. We also have been given enough information for us to find the rate the height is changing and the ratio that the radius changes as the height changes. The change in the volume of the water is the difference in the fill and leak rates. dV over dt is equals to dF over dt minus dL over dt. Therefore, we can say that the leak rate would be the difference in the fill rate and the actual rate of increase in the volume of the water. dL over dt will be equal to dF over dt minus dV over dt. This is done by transposing. Next is to equate the volume of our tank, which is 1/3 pi r squared h. Since the inverted conical tank has a diameter of 10 feet at the top, its radius is 5 feet, since the radius is the half of a diameter. By similar triangles, the ratio of the radius of the water to the height of the water in the cone is r over h is equals to 5 feet over 20 feet or 5 over 4. Thus, r is equals to h over 4. This was derived by multiplying both sides by h. Thus, we can express the volume of the water as a function of h by substituting h over 4 for r, which yields v is equals to 1/3 pi multiplied by h over 4 squared h, which is then equal to 1 over 48 pi h cubed. Differentiating with respect to time yields dv over dt is equals to 1/16 pi h squared dh over dt. We are already given the rising rate of 1 inch per minute, which is equals to 1 over 12 feet per minute. This is done through converting our inches to feet. When h is equals to 16 feet, thus, the rate at which the volume is increasing is 1 over 16 pi times 16 feet squared times 1 over 12 feet per minute, which is equals to 4/3 pi feet cubed per minute. We go back to our equation in getting the leak rate. Since the fill rate is 8 feet cubed per minute, the leak rate is 8 feet cubed per minute minus 4/3 pi feet cubed per minute, or simply 8 minus 4/3 pi feet cubed per minute. And that's it for this equation. Hope you understood this tutorial, and if you have any questions, comment down below and don't forget to click the like and subscribe button.